Right, thanks for the introduction there. So I am going to be talking about how we hack ships today. My name's Andrew. I work for a pen testing company, but I used to work on ships. This is me 16 years ago as a marine engineer on a container ship in the Suez Canal. My forehead is probably about as shiny as it was back then as well. I used to work on things like this. Massive container ships, 300 meters long, 330 meters long, carrying somewhere between 6,000 and 8,000 containers. So the biggest container ships back in those days. It's given me insight into how these things work and what they do. So I'm going to take you through how we hack ships, what we do, and what a security consultant, a pen tester, someone who works with ships, what they can do to improve the security of these. It's going to be a bit of fun though. At the end of this, hopefully I'll show you how I was sat on my sofa in my pants, taking control of a cruise ship over TeamViewer. The first thing I want to talk about is accurate threat models. To work with any system, to work out what you can do to impact it, you need to understand how it works. What's the worst thing you can do? What's the likely things that you can do? What attacks can you carry out? So let's talk about ships. Now this is the engine on one of the container ships I worked on. This is just the top bit of the engine. That red box there is just the exhaust valve of one of the cylinders. They're really, really quite big. They go from, well, they're 3 stories high from top to bottom. Looking up, you can see there's ladders. You've got the bottom plates, the middle plates, and the top plates. You've got 3 different levels on those engines. This is one of the 2 turbochargers on that engine there. So this here is the inlet side, so that's compressing the air to force air into the engine. The other side of it is the exhaust side. This is a cross-section, not my picture. I've never chopped one of these engines in half, and that's a banana for scale. Obviously, you have to shrink it down a little bit. But you can see there's a man stood up there on the top. These things are genuinely huge. This is doing something called taking bores on the main engine. So this is one of the cylinders. We've taken the top off of it, and we're looking to see how wide it is. It's 96 centimeters across, almost a meter from side to side. We're checking how much it's worn. That was on one of the ships I was on before I got on board. So just to outline that, it's 3 stories high. The one we looked at there has got 10 units. We call them units, but they're cylinders in reality. It's 96 centimeters across, but 2.4 meters stroke. So that piston goes up and down 2.4 meters. That results in 1,810 litres per cylinder. It's a little bit bigger than your normal engine here. It's a 2-stroke diesel engine, though. It's not a 4-stroke. It's very, very different. But as a result, that huge stroke, it can only go at 102 RPM. That's the maximum rate that it can spin round at. Compared to a car engine that can do 6,000 RPM, it's pretty different. But it still develops 55 megawatts of power. This is a small power station, dumping that power into the sea. And as a result, it burns about 250 tons of heavy fuel oil every single day. Absolutely massive. How do you get that power from the main engine into the sea? Well, you need a prop shaft. It's a massive chunk of steel that runs from the main engine all the way down to the propeller. There is no gearbox. If you want to change direction, if you want to go in reverse, you stop the main engine and you turn it around and make it go the other way. So how big is the propeller on one of these things? Well, it's really big. This is the Ned Lloyd Southampton when it was in dry dock. So that is the propeller there, absolutely huge. That's the old man, the captain, stood next to it, potato quality because it was kind of year 2004 or something like that. A really interesting thing is how do you work out how much power this main engine is putting into the sea? How do you work out how much power that engine's developing? Well, we've got a power meter, like you'd have on a bike or a car or something like that. It works out how fast it's spinning, and then it looks at that massive chunk of metal, that prop shaft that I just showed you, and it works out how much it's twisting. It looks at the torsion on that. If it twists more, you're developing more power. At this moment in time, we're developing 33.76 megawatts of power. Not that much at that point in time. Now, to support one of these engines, you need loads of things called ancillaries. You've got pumps, loads of pumps to move cooling water, seawater, oil, and so on around the engine. You've got to dump that power, all that heat that comes from the engine, the waste heat, into the sea. So you've got heat exchangers, which are those things I'm showing you up on the right-hand side there. They're massive titanium stacks of plates that change from seawater through to cooling water. How do you start one of these engines? Well, you don't have a starter motor. You start them with compressed air. These are the two start air bottles on one of these main engines. Each one of them holds air at about 30 bar. So that's a really, really high pressure, 450 psi or so, and you inject it into the cylinders. Like you would with a distributor on a car, sending sparks into cylinders, you push air into the cylinders. That's how you start them. Of course, you've got to fill them up with air, so you've got air compressors. 3 air compressors there, really, really dated design, going back to the 1950s, but powering these modern engines. Where do these air compressors get their power from? Well, you can't get the power from the main engine because it's not running. So you have 4, maybe 5 diesel generators. Each one of these sits at about 3.4 megawatts. So you can generate 12 megawatts of power independent of the main engine. That's obviously quite a lot of power. But how do you start these diesel generators? Well, if you need to start these, you need to fill up another tank full of compressed air, which needs another smaller engine called the emergency diesel generator to start it. It's starting to sound complicated. It's a long chain of things that need to work for the ship to go and run. So if you want to go from a black start, no power on the ship, you need to start the emergency generator, run a single air compressor, charge the generator start air, start an individual generator, run more air compressors off the back of that, charge the main engine start air, and finally start the main engine. That's quite a big chain of things to occur there. Now, in emergency conditions, sometimes all of the automatic controls that make you start and stop that main engine might break, and you'll have to control the main engine manually. On the side of the main engine, there are literally sticks that let you control the throttle on this thing. You call it riding the sticks. So you've got one that chooses which direction it goes in. You've got one that chooses whether you're going, and one that chooses what throttle you're at. So you sit there and you've got to regulate it manually if all the control systems fail. If you're running under automated systems, you get about 10 or 12 changes of direction. So if you want to go forwards, backwards, that start air will last 10 or 12 starts to the engine. If you're doing it manually, riding the sticks, you're down to 3, 4, or 5 starts before you run out of air. It's a massive difference. So why am I talking about this? Well, a weird thing about container ships is you've just got that one big propeller. You've just got one rudder. If your propeller's not spinning round, if you don't have any forward momentum, the rudder does not do anything. There's no water flowing over that rudder. You will lose control. You cannot steer. And that causes problems like this. So this is the Milano Bridge. This happened a few years ago. It was a very, very large container ship that just came out of dry dock. You might notice something about it there. It looks very, very high up out of the water. So they'd just come out of dry dock. There was no cargo on board. They hadn't taken any ballast water on board. The prop was half out of the water, and they had virtually no maneuvering power. Now, if you can identify threats that any of those individual stages there, through cybersecurity, you could stop them working. You can cause things like this to happen. There are lots of single points of failures in ships. Another thing, nearly all ships these days use something called an ECDIS, which is the charting system. So if you want to plot a passage, if you want to know where you are, this ECDIS shows you. The thing is, when I worked on ships, you used to have a paper chart table. You literally had paper charts and someone would plot where you were going on there. You could plot your passage. The thing is, nowadays, they've completely got rid of these. You have 2 ECDIS, no paper charts. From a perspective of an attacker, if I can take out both of those ECDIS, I've stopped that ship working. It can no longer sail. These ones seem quite obvious. If I can stop the engines, if I can stop navigation, that makes sense. But what's this? This is a fire alarm. It seems kind of boring. Fire alarms are not the most interesting thing in the world. But if you're on a passenger ship, specifically larger cruise ships, they've got 3 fire alarm systems. One of the biggest threats to life on ships is fire. You really, really want to detect fire quickly and put it out. So they have 3 fire alarm systems running together. One of them's there for pure redundancy. If we take it out, if it stops working, you've still got those 2. Everything's fine. If we take out 2 of those fire alarms, you've got a bigger problem now. You need to do fire watches. A member of crew will need to walk about the ship, pretty much full time on a big cruise ship, to check nothing's on fire. So things are getting quite awkward at this point in time. If I take out all of the fire systems, we now need to disembark all passengers until the fire system is back up and working. If you've got 6,000 passengers on board, you're on a small Mediterranean island, and you now suddenly need to get all of them back home, that's going to cost you big money. How did we identify this? The day before we got on a ship, a fire alarm engineer got on board. He updated the firmware on all 3 of them at the same time and bricked all 3 of them. Luckily, there were no passengers on board, but we were told about it immediately. I was not aware of this limitation. And from a threat modeling perspective, it's important to know these things. But of course, I'm talking about cyber threats here. Well, we did manage to get root access to the fire alarms. It was pretty easy. Another system linked into them. We found a script file that had the password and the username to download information from the fire alarm to feed it to another system. We logged into it. It wasn't the root user technically, but we could still cat the shadow file, destroy the file system, and above all, we could VNC into the fire alarm. Why has a fire alarm got VNC enabled on it? So we could take that out and cause harm to that vessel. Another one's the voyage data recorder. It's the black box on a ship, the VDR. And again, we got network access to this, and we thought we'd have a look at it. What could we do with this? Well, first off, it had a very low level of access, crew01 with the password crew01, and we could log into it. It's in the documents, it's easy to find. And we found you could download a backup from that, a backup of the configuration. Now, with a bit of reverse engineering, we realized you could pull out the password hashes for all of the users on there. I've had to redact them, but we put those password hashes through our cracking rig, and we quite quickly got a password for the account webadmin. And we could now log into the admin interface, the web interface, using this other account. From that perspective, we found you could then edit the password file. You couldn't edit the shadow file, but you could edit the password file. Now, webadmin couldn't log in via a shell at that moment in time. For some reason, it was running user bin password when you tried logging in with webadmin. But we could edit this file. So we changed it to bin.sh for that particular user. And there you go. We've now got a shell on the voyage data recorder. The file system was not protected in any way, shape, or form. An RM-RF on the root of that would have trashed it. There is only one of them on the ship. That would have been it. It would not be able to sail at that point in time. So it's always important to think about the different things you can do from different perspectives. It's not always steering a ship remotely. That's not always the biggest threat here. What's the likely thing that can impact the ship? Now, kind of coming back to pen testing, and I want to call this an unfair advantage. I'm fundamentally a really lazy person. If I don't have to do work, I'm not going to do the work. Other people like to call it efficient. I prefer lazy, to be fair. But this is key. Black box pen testing. It relies on your tester being better than your attackers. And I don't think you can rely on that anymore. Attackers, well, they've got more time. If you pay me 2 weeks to do a pen test, I'm going to spend 2 weeks doing a pen test. I'm not going to spend 6 months doing it. They've probably got more skill. I like to think I know what I'm doing. My colleagues probably don't. But our attackers, people can be experts in the industry. They can be insiders from companies that produce these systems. But above all, they have to obey fewer rules. They can break into other systems. They can look at things that aren't in scope. So we need to get a leg up so that we can do things that attackers can do, but more quickly. So I'll give you some hints to how we do this. One of the really, really useful things we found is whole vessel traffic interception. You might have seen one of these little boxes before. It is just a network tap. You pass a network through it, and all of the traffic will come out of that monitor port. There's no chance of you injecting traffic. It's safe in those respects. That brief disconnection is fine. So we're sat there on the satellite connection on an oil rig, so we can see all of that traffic going in and out. And for that whole week we were there, we were just intercepting all the traffic. A real attacker probably wouldn't end up in this position, but we did. And what we managed to do was we managed to get an FTP user account and an FTP password, plain text, going from the oil rig through to the corporate side of things. It turned out that user was, in fact, a domain administrator. It was synchronizing just some basic files between two systems, but we had the password. And it didn't really matter that that was what it was meant for. We had domain admin. That's a screenshot from Bloodhound. It was actually a third party that wasn't HP, obviously, by the beginning of the names there, but we could access everything at that point. And it wasn't just on that oil rig. It was everything. It was every single oil rig in the fleet. It was the corporate offices. Domain admin across everything, just because an FTP password is being sent in the plane. Another advantage we have is, first off, we can speak to people. We can say, how does this work? What vulnerabilities are in this? Most of the time, someone in that company knows these vulnerabilities anyway. They know something that happened in the past. They know some password that everybody knows that's common across all systems. But you often get things that happen the other way, where they say things are secure. And this was on one test where they said the drilling control network is entirely air-gapped. So the drilling control network is the bit on an oil rig that deals with the drilling, not the propulsion, the drilling bit. And we thought, well, let's look at the documentation. We're not an attacker. We've got the advantage of having these documents in front of us. So this is a diagram of the drilling control network. It's a large loop network there. Amazingly, those chairs, the things where you actually control the drill at the top, are called cyber chairs, which I really, really like. But we looked at that and we said, well, they said this network is air-gapped. And I thought, well, that's really strange there, because I'm sorry it's a bit fuzzy here. There's this kind of cloudy things that links off to something called an FW, a firewall. It wasn't air-gapped. It was connected via a firewall. Now, in this instance, that firewall was incredibly well configured. But there's a very big difference between air-gapped and a firewall connecting to that system. Another thing we find is that every vessel will have had changes made to it. People want to get their jobs done. They want things to work. When you're on a ship, you don't have access to Google at high speeds. You don't have the liberty of being able to order things from Amazon. So quite often your goal is to make things work. That's your primary goal. So if you have to run a patch cable between two switches that make things work, go for it. It works. My job's done. But the problem there is things end up deviating from documentation. Now that thing there, that yellow box, is a Fluke network tracer. You plug it into a network cable at one end and you wave that about in cabinets at the other end, and you can find where those cables go. It's been absolutely invaluable working on ships. We had this connection here, this service PC. There was a PC somewhere in the accommodation on this oil rig that connected through to the VSAT systems. It took me about 3 hours to find it using a cable tracer. Another advantage we've got is physical access to the devices. Now, if any of you have ever worked with network switches and firewalls, particularly Cisco, you'll recognize the console port. It's either USB, RJ45, DB9, but it's a serial connection into that device that allows me to interact with it. Now, quite often people put a password on that serial connection, so you can't just log into the device and do what you want. But Cisco have really helpfully added this thing called password recovery mode. What it means with physical access, you can reboot the switch. You reboot the switch, holding down the power button, doing something strange with removing a CF card or whatever, and it will let you read the configuration of that switch. The idea is that you could then reset the password and gain access again. You've got physical access, so resetting a password makes sense. It's really easy to do. Reboot it. The only thing with Cisco devices, sometimes they take 6, 7, 8 minutes to reboot, which is a crazy amount of time in an operating environment. But one of the big things with Cisco devices is you can hash your password sometimes, but there's a different type of password called Type 7 in Cisco configs where they're encrypted. It's a hard-coded key. You can turn those passwords back from those encrypted values into the raw passwords. Now, if that password works on this device and every other Cisco switch on that oil rig, or every other Cisco switch across the entire fleet, we've now got a big problem. Another thing we found was the use of what's called out-of-band management. Now, if you lose your main connection, SSH into your switches or so on, you want a way to dial back into that vessel so you can remotely access the switches and the firewall and reconfigure them to get that access back. So there's a common device we find called an uplogix. It generally connects using slow-speed satellites, something like Iridium, or we're talking properly slow speed, like modem speeds from the mid-90s. And it allows you to connect via serial console into lots of different devices. It'll generally be the VSAT modem, router, firewall, and so on. Now, really strangely, rather than you type the password in for all of those devices that you want to access, it stores the passwords for the router and the switch and so on locally on the device. I cannot quite work out why. It has a FIPS compliant mode. You can properly put this thing into a hardcore security mode so that recovering those passwords is difficult. But but we had physical access. So I took it apart, as you do. It was broken, actually. The fan in it had failed, and it wasn't working. I fixed it and put it back. So, I was being useful. And we pulled the hard drive out, read the encrypted passwords, and worked out how they encrypted the passwords. Well, yeah, they encrypted them with a hard-coded key. Builder Muck Dizzy password. Now, are any of you fans of Bob the Builder? Probably not, but anyway, Builder, Muck, and Dizzy are characters from Bob the Builder. So yeah, we had the passwords for all of the devices, the router, the switch, and everything. Now, I'm not going to say they were based on the name of the vessel, but they were based on the name of the vessel. This is a key principle. The compromise of one device should not lead to the compromise of many. If I've got one switch in front of me, if I can get a password hash or a password off it, I should not be able to use it on other devices. Unfortunately, it rarely turns out like that on ships. Hidden stuff everywhere. Now, Ryan, who's sat here in the front row, a few years ago with a completely different project, a crypto wallet, said, much of hacking is about understanding systems better than those who built them, and using that knowledge to do what is supposed to be impossible. Now, there's got to be nuance around this. There was a big discussion earlier this week on Twitter, but we quite often get on ships, and our goal is to understand those systems. Our goal isn't to just make them work. Our goal is to find all of those weird connections, understand those strange protocols, exactly what's going on. And that's what we do. We quite often get on a ship and we find things out that no one who works for that company knew about. I'll take you through a few of these. Now, the way that systems used to work when I worked on ships was you'd have your engine room systems, your bridge systems, navigation systems. They'd be completely air-gapped from the corporate side of things. There would be no connection between them whatsoever. So the only way you could impact navigation propulsion would be if you physically connected to them. But that's been eroded. People want to remotely monitor what ships are doing. The largest cost by far for big container ships is fuel consumption. The fuel costs a huge amount of money, so they want to see how efficient they are in using fuel. Now, the captain, the chief engineer on this vessel, they both knew there was some kind of remote monitoring that meant they could work out how efficient they were being with fuel. Shoreside knew that system existed. They were paying for it. But no one actually knew where the system was on the vessel. They literally didn't know. So we spent a rather hungover morning rooting around on this ship trying to find this thing. And at the top there, you've got the voyage data recorder, the VDR, the black box. Now that brings together lots of systems. It monitors all of these connections, where you are, how fast you're going, what you're saying. And we thought, well, a remote monitoring system's probably going to be close to the VDR. And you see that little panel in the middle there? It does have a label on it, but that label wasn't meaningful. It was screwed into the wall. We unscrewed it, and there's our remote monitoring system, screwed into the wall. It was really quite hard to find. Amusingly, my colleague unplugged one of the network cables, and it dropped down into the cavity. Yes. Anyway. We had a look at this thing, and it had loads of serial connections coming into it. Industrial control systems love serial. It's a great way of transferring data at low speed and entirely reliably within a defined time frame. But you'll notice something there. There's only 2 wires for each one of those pairs. You've got white and orange, you've got white and green, white and blue, and every third one's missing. It's really, really important in terms of security, this. So we don't understand that connection until we found the device. The blue line represents something I don't understand. Now, if I want to communicate over serial, we've got a receive and a transmit. It's 2 different sides. So we can transmit data through to the other end, and then we receive it. Now, the way that lots of systems on ships work is they just broadcast that data. They just keep on sending out the data again and again and again. There is no concept of me asking for the data. They'll just shout it out. So that red connection, the transmission through to the control systems, doesn't actually have to be there. And this is what they've done in this case. They only put one of the wires there. This is essentially a data diode. You cannot get data from the monitoring system through to the control systems. So we'd proven that that system was safe from controlling the vessel. It's really important, this. When you're testing a ship, it's not always about showboating. That was not meant to be a pun. It's not always about showing that you can hack it remotely. Sometimes it's about proving things are safe, making the client feel happy. But it's not always like this. This was on a container ship, and we found this little box, a little rugged PC, that was just kind of hidden away in a server rack. We thought, well, what's that? Let's look into it. If you've worked in any industrial control systems, you'll recognize these. It's an IP to serial converter. It takes serial in one side, that receive and transmit, possibly RS-485, a slightly different protocol, and it converts it into IP that you can feed into a computer. Just a protocol converter. They're everywhere. Now, these were involved with this little box called Blue Tracker. And we kind of traced it out, and we worked out what was going on. It was taking one feed from bridge systems, the ECDIS, which is the charting system, position, speed, and so on. And it was going also to the main engines to find out how fast the engine was going, how much fuel it was using, and so on. And again, we wanted to understand that. Now, again, after a lot of digging about, what we found was this is the ECDIS. The ship's electrician has taken the panel off of it, and we found that that serial connection was broadcast only. The speed, position, and everything from the bridge systems being sent from them to Blue Tracker. There was no way for me to go back in the other direction. So we've said that one's safe. There's not much you can do with that. So then we thought we'd look at the engine room side of things. It was using Modbus. Now, Modbus is different to normal serial. You've got to poll for values. It doesn't just broadcast what it wants. You've got to say, I want to know how fast the engine's going. I want to know what the cylinder pressures are, and so on. So it's a request response. You need that transmit and that receive side of things. You cannot cut one of those pairs. Now, it might be the case that all those requests that are being made is just requesting values, not carrying out any actions. But we've got no way of confirming that. There was no documentation. No one understood that system. There's a PLC sat on the side of the main engine that we can make requests to. Not a good position to be in. So at the moment in time, we've got control possibly of injecting things onto the main engine. But you say, well, no one can do that remotely. Well, the thing was, of course, we had TeamViewer on that box. The best thing here was that for Blue Tracker, this system, our client who operated that vessel had not been paying for this system for 4 years. TeamViewer was still completely active on this, so someone could have connected in via the third party, via compromising the third party, and injected traffic. Not a great situation. So this was about risk awareness. Disconnect the system, decommission it, just get rid of it. Another one we found, this is one of the generators on an offshore tug. And I'm looking in the little box on the top of it to understand what's going on. And visually inspecting it, something kind of stood out as interesting, that little yellow box on the top right-hand side. So we look at that, and it's a little router, an industrial router. Now, the first thing that piqued my interest was the fact it had an antenna connection on the front of it, and it can be a cellular modem. It can have a completely remote connection, but we were on the bottom plates of a ship. There's no way it's going to get a signal. There was no antenna connected. But there was something else that interested me on this. There was a label saying LAN/WAN. Now, if you look at your router at home, it will probably have a WAN port for the internet, the wide area network, and a LAN port. They're probably going to be physically separate. Not here. It's the same port. Now, how are you going to provide strong separation to traffic on a router when you're using the same port? Especially when someone's got local access to one of those networks. So a bit more tracing those networks out, and we found it looked a bit like this. We've got our ship plan at the top there running on a 192 network. We've got our little router sat to the side in yellow, and then that routes over to the generator network on a 172 network. So 2 different IP domains, 2 different subnets. And the idea is that little router routes between the 2 networks. But the thing is, I don't have to obey any rules. When I'm on the ship's network, I don't have to be a 192 address anymore. I can become a 172. So to bypass this security control, to bypass that router, all I had to do was set my IP address to a 172 range. I was through to the generator controllers, and I had control of the generators from one of the cabins on the ship. How did I do that? Well, they'd given us little boxes in the cabins that let us watch IPTV. That was on that same network, that 192.168. I changed my address to 172, and we were through. It did take a bit of knowledge again. We're pen testers. We're not hackers. We want to, well, we're kind of both, but we're not a malicious attacker. I could go down to the engine room and see that the diesel generator controller was made by DEEF. I could see how it was working. I registered on the DEEF website, downloaded a nice little tool that allowed me to communicate with the generator. That kind of black line that says GB there is the breaker for that generator. I could click on that, and it would disconnect the generator. You could black the ship out. So not great in the general scheme of things. Same shit, different ship. Now, I don't know if we're going to call this a 0 day, but I've never mentioned this password before, but I'm fed up with this company. Marine Exchange, MXP. Every single cruise ship we have ever been on, and we have got domain admin on every single cruise ship we have been on, we have done it via MXP. I'm not joking here. It is everywhere. Look at the names along the bottom there. It's every single crew line. What is MXP? Well, I'm not really sure, to be honest. It's a passenger management system. It's a stores management system. It does everything on a ship. But the way it's architected and the way it's secured is just terrible. It's a server thick client application. A lot of things are thick clients on ships. So we've got a server side and we've got a client side. But we want to understand how that works. Well, an interesting thing about the way it works is to get the settings for the client, first off, it goes over SMB to a file share, and it will pull down the settings in an INI file to the client so it knows which server to connect to, what password to use, and so on, how to authenticate to it. So it pulls down that file, and it turns out that MXP server is actually a SQL server. So it's using SQL to communicate with the server. Let's look at that INI file. So the username there, pos to MXP, underneath it is an MXPDB password, the database password. It's encrypted using a hard-coded key. I'm not going to say the username and password are the same, but the username and password have some commonality between them. Of course, someone who does this, who leaves a SQL password in an INI file poorly encrypted like this, probably isn't going to understand how to harden SQL Server. So of course, we can log in, we've got pretty much SA, and we can use XP command shell to gain admin credentials on the underlying box. We've done this on so many cruise ships, it's not even funny. The companies have stopped reporting it to MXP because it's just not getting fixed. Another thing we often find on ships is that they use something like Veeam to perform backups of VMs. On a cruise ship, there can be 80 to 150 virtual machines running everything. Massively complex. You want them backed up to a central store. Now, the thing is to back up a virtual machine, you need to have some form of high privileges, some way of accessing the data storage that underlies it. So Veeam stores credentials, generally for Windows, for Linux, and so on. So it can log into these ESXi boxes and so on and pull those backups back. And it can't store them hashed. They've got to be encrypted because it uses them. The thing is, again, it uses a hard-coded key. So there's a little script you can find on the Veeam forums that if you're logged in as a user who can use those credentials, you can recover the credentials from Veeam, and they will work across so much on a ship. You can log into things that aren't things you get access to as domain administrator. It's absolutely crucial. People see domain admin as being like the end goal. That's not our end goal. We want to compromise and ruin everything. The gins are turning up. Adverse impact. Another thing on a ship that's absolutely crucial to operations called the load computer. It takes the levels in the tanks, how much cargo you've got, how many passengers you've got on board, how many bananas you've got on board. Literally, you have to tell it how many bananas you've got on board. I really like bananas. This is just a screenshot to show you what it looks like. It's vital for safety. You can put it into another mode. If you hold the vessel, if you're taking water on, this goes into an emergency situation that will tell you if really bad things are going to happen. So it's crucial. You'd hope it would be secure. Now, the thing is what we found was it needs to pull those values for tanks. You need to know how much fuel, how much ballast water. If you've got hull stress monitors that measure how much the ship's bending, then you need to pull these values into the load computer. Manually entering them is time-consuming and error-prone. So what they do is they read them through serial. So the bridge control systems will be reading hull stress monitoring tank levels all over serial networks. And we want to read them. And our little friend, the IP to serial converter, comes in. So we've got that. And we have a load computer server. It has an IP to serial converter that connects into those buses and will pull those values back. Now, that load computer server will be buried in a server room somewhere. It might be behind the bridge, below the bridge, or somewhere else. But to actually use the system, you want to be on the bridge. So they have a user interface computer, a separate device, and somehow they need to communicate with each other. Now, the thing is that vendors, they get on board ships and they want to install these systems. They just want them to work. The load computer company doesn't know to go to IT for a cruise company and say, we need to be able to patch on a private network between these two different places. What they do is they come along, they've got their load computer server down 2 decks, they've got their user interface, and there's 2 network ports next to them. They're just going to plug them into those network ports and hope for the best. So they need to talk to each other. But what they found was they could plug into any ports in the walls, and those 2 devices would talk to each other. They get a DHCP address in the 192 range. You could just communicate. It was all fine. It worked. They might have only been on board for 8 hours. Job done. Let's get off. The problem was that mechanism of plugging into a wall port and getting that 192 address was what they called tar pitting on this vessel. If I was in the bar, if I was in the pool, in the cabin, and I plugged into a network port and I didn't have an 8021X certificate or a valid MAC address, I would just get dumped into this tar pit. You'd get a holding page saying you're not supposed to be plugged in. If you tried accessing the internet, you should pay for internet. But the idea was this improved security. It meant that people couldn't arbitrarily access the corporate network. The problem was that load computer, the UI and the server, were in the tar pit. And I worked out, one evening sat in the bar, you could also plug into a wall socket there and end up in the same tar pit. There was no client isolation. It's a wired network. You're in the same subnet. So we've now got network access to the load computer. The thing on ships is lots of systems have to start automatically. If you black out, lose power, you don't want to have to type in a 16-character password into your load computer to get it working again. So auto-login is incredibly common. Now, this system's made by a company called Napa. And I'm not saying that the username's OB Napa and the password's Napa Oi, and it's been the same on every single ship we've ever been on, but it is. We've now got admin access onto that load computer server from the bar. The thing is, it's connected to this IP to serial converter. Now, again, I'm lazy. I could do some kind of advanced thing and inject some genuine values and make something crazy happen, or I could just spam noise into that serial cable. I spam noise into that. All other consumers on that serial bus will see that noise, and you've now got unreliable data. There is no other easy way to get these bits of data. If you want to find out how much is in your tanks, doing that manually is a massive pain. So yeah, that one was an interesting one. We've only seen that once, though, the tar pitting thing. Another job, an oil rig. So this was an exploratory drilling platform. Absolutely massive. We had free run of it. It was brilliant. I could just go and do what I wanted. It was in what's called warm stack. So it's running, the generators are running, but it's not drilling. So there was a skeleton crew on board, and we were just told, go and do what you want. But an interesting thing on drilling rigs is if you go out from the accommodation, where the offices and cabins are, and you go out onto the drilling floor, there could be the potential for explosive gases, lots of bad things to happen. So you need to put a boiler suit on, you need to put safety boots on, goggles, hard hat, check out a radio, gas detector, all of these different things. That's a massive pain. That's a barrier to me going out onto the drilling platform. But the thing was that drilling control network that I mentioned earlier, that sat on the drilling part of it, not the accommodation. So people are lazy. People like convenience. They don't want to get dressed up to go and do all of this stuff. They'd rather just maybe TeamViewer into that. So the ideal situation here is we've got all of our drilling control networks sat there completely air-gapped from the business networks. But that wasn't what we found. So I went out into the equipment room below the cyber chairs, and I found this PC. Amusingly, the password hint underneath it did have a password on it. It said, "Who do you work for?" So I typed in the name of the company. It needed a capital letter at the beginning, so I got it wrong the first time, but not much of a barrier. So there's this PC, and I did IP config. And there was something interesting I saw. First off, this was a Kongsberg Maritime PC that had been repurposed. It was from the control systems of the vessel. It had just been taken out there. I knew that because of the names of the network. But also, there was one Ethernet adapter in it that had an IP address, but the one below it in red there, it said media disconnected, but it also had a DNS suffix of corp.local. Now, the way that Windows works is when you plug into a network and you get a DHCP address, the DNS suffix populates itself. When you unplug it, it persists. So to me, this is a clue saying that that network connection had been plugged in the past. Why is it being unplugged? What's going on here? I mean, I like to think I'm a detective, but I just looked to my left, and there was a network cable, literally unplugged from a socket. And I thought, well, what happens if I plug into that? And I plugged into it, and I got an address on the corporate network. So now we've got that jump box going between the business network and the drilling control network. It did have TeamViewer on it. It was personal TeamViewer rather than the corporate one, because this was shadow IT, something that wasn't authorized. Not great in the general scheme of things. So here, really, what they had done is they hadn't provided an authorized way of remotely accessing the drilling control network. So someone went and did it themselves, and they did it incredibly badly. The next one, fingerprint access control. Sounds like a great idea. I know people have got some complaints with biometrics, but on a ship, you want to control access to the bridge, to machinery spaces, and so on. So this ship added fingerprint access control. Seems like a great idea, doesn't it? Until you meet an engineer. Your hands end up filthy, absolutely filthy. So what had happened was they found that these biometric readers would not read fingerprints for engineers. So what did they do? They gave every engineer a master key, a physical master key for the lock that can bypass it. So now we've got 40 engineers who've got master keys that they can lose. You can't revoke those credentials. Absolutely crazy. It's a security control that was implemented, and because it wasn't done well without considering the users, it made things worse. The other one, HMIs, human-machine interfaces. These are the screens on ships that you interact with machinery and so on. And there'll be hundreds of them on a cruise ship. There'll be ones in the HVAC rooms doing the air conditioning. There'll be ones down in the engine room. They'll be everywhere. And we've gained significant access before walking into a swimming pool control room and getting an HMI there, breaking out of it and doing bad things. So people want to lock them, like you'd lock a normal laptop or a desktop computer. Your screensaver comes on, you need a password. So again, they implemented locking of the HMIs. You had 2 minutes. So you'd log into it, you get 2 minutes, and you'd have to log into it again. Now the thing is, and I know this, I've worked on ships, you might be starting up a purifier, tending to the ship tank, whatever it is, but you will make it do something on the HMI, you'll go and do some physical work, and then 3 minutes later, you'll come back to check if everything's working. Now, the terminal is locked. You've now got oil or poo on your hands, whichever one it is. So what happened here was that the engineers worked out there were 2 high-level user accounts on the ICMS system, the control systems, C and E, captain and engineer, that had a fairly easily guessed password that didn't have that timeout. So what we found was most of the HMIs on the ship were just logged in as these hard-coded users. They weren't locking. So again, someone had added these controls, and they'd just not done it particularly well. Simplicity can lead to vulnerability. Now, a massive thing that we found over the last 10 years is that ships have moved towards what we call converged networks rather than discrete networks. Previously, you'd have passenger networks, CCTV, corporate, operational technology, all on physically separate switches, physically separate connections. The thing is, they've all got so complex that running all of these different cables and having all these different infrastructures become really complex. And you end up with stuff like this. Cables everywhere. You can't manage this. You can't manage it remotely. So they've moved to converged networks, essentially using VLAN trunks. So you run lots and lots of different network connections all down the same cable. And that's great if I come at it from an attacker's perspective on an individual network. I can only compromise that individual network. But we might have physical access. We might be able to take control of one of the switches with a shared password. So if I can get on that VLAN trunk, if I can compromise a switch, all of those networks are compromised now. Now, one of the things with large ships is they're divided into fire zones, watertight zones, vertical barriers. And this changes how they implement the network. You can't just run cables everywhere. It's fairly easy to run cables vertically. It's really, really difficult to run them horizontally. And this dictates how the ship's architected. We have these things called RDPs, remote distribution points. There'll be one per fire zone, and looped off them will be what are called cabin switches. They're access switches. They take a VLAN trunk through them, and they'll break out different network connections. So there'll be lots of those. You'll tend to have 2 sets of RDPs for redundancy, port and starboard side. And hanging off them, you've got VSAT, the satellite connection, engine room systems, bridge systems, and so on. And that trunk running through that RDP loop, running through the cabins, carries lots of network traffic that you might not necessarily want to see in your cabin. To give you an idea of scale, this is one half of a patch bay for one of those RDPs. And hanging off each one of those loops is about 10 cabins. So it's a huge number of switches. Let's break that out a bit. So we've got our cabin switch. Now, each cabin switch has 2 cabins hanging off it. So we've got cabin A, and our TV will come over the IP network there. Our VoIP phone will come over that IP network. The cabin control system that controls the lighting, the HVAC, the door, you can lock and unlock the door through it, and the water temperature all comes through that network. So that VLAN trunk gets broken out into the individual cabin. We'll have cabin B, the other side of it, 2 cabins. But for convenience, because it's difficult making those connections across a ship rather than down, we'll also have things like Wi-Fi access points and CCTV cameras hanging off that network. That means if I gain physical access to that trunk, all of those networks are mine to interact with. So how do we do that? Well, we first did this when we were on an operational cruise ship. I couldn't sit in a passageway and start unplugging things and messing about. So we needed to do it relatively covertly. So what I did first was I unplugged my TV and my VoIP phone. I wasn't watching TV. I'm allowed to hack a cruise ship. There's more interesting things to do. I unplugged my VoIP phone. So now I've got a connection going from my cabin out to the cabin switch. I then went to the cabin switch, which is just in a panel in the passageway, very little physical access control, and I disconnected the cabin switch from that loop and put my TV and VoIP phone into those connections. So now it's going through my cabin, and then put a switch in my cabin. So now I've got the VLAN trunks coming through my cabin. I can't get TV in my cabin anymore, but that's not really a problem when I want to steer a cruise ship remotely. We've managed to do this in around 2 minutes, give or take, so we can open up the panel in the passageway, open it up, connect to that, and patch it through to our cabin in about 2-3 minutes, give or take. I've done it on a ship, and no one said anything, and I've got access to all of these different networks. So now we've got that attacker switch. We'll be honest, the TV system, the passwords are all default. The VoIP phones, the passwords are all default. The Wi-Fi had some slight problems. The CCTV, to view those cameras, there was no control on that. You could just view all of the cameras, several thousand cameras across the ship. Obviously redacted somewhat. But we also had access to the cabin control system, which let you change what the lights were doing. Now, this isn't an image. This is an image off the internet. It's not what we were allowed to do. We did go and say to the client, can we write rude words down the side of your ship using the lights in the cabin control system? And they said no. Really disappointingly, I found out on another ship, you can't always turn the lights on and off using the cabin control system. They just make a spreadsheet and then send someone who's not paid very much to go and turn the lights on and off in all the cabins. Right. That's been all the things we found on ships kind of laid out. Let's bring that together. How could you control a cruise ship remotely? Speed 2 cruise control, my inspiration for my entire life. Still not met Sandra Bullock, though. So the main thing on a ship that controls the engine rooms, navigation, and so on is called the ICMS, the Integrated Control and Monitoring System. That does pretty much everything nowadays. If you turn a rudder, if you start and stop the engines, it could all go through this system. Very, very powerful and important. But on a cruise ship, you've also got a very important system called the SMS, or Safety Management System. This is a specific room, generally behind the bridge, the safety center, where if there's a fire, if someone goes overboard, if you need to abandon ship, it gets coordinated from here. And it brings together everything. CCTV, watertight doors, ventilation, firefighting pumps, energy. Absolutely everything comes into the SMS. As a result, it's got connections through to everything. From an attacker's perspective, it's very interesting. Our goal was to take control over the ASI pods on the bottom of the vessel. Modern cruise ships are powered by things called ASI pods, gigantic electric motors that can physically rotate. There are no rudders. That was what we wanted to do. And we thought, let's give it a go. Now, we've already got that attacker switch on the network. So we've got the ability to inject traffic onto trunks. Because we had physical access to the switch, we managed to dump a configuration from a switch. We managed to get a pass-through from that. And oddly, it worked on one RDP. It only worked on one of those remote distribution points. It had been changed on all the other ones. The password we recovered was the name of a vendor, in leet speak to make it a little bit more difficult to work out, but it was just an omission. Someone had made a mistake and left it on an RDP. That meant we could reconfigure how network traffic was routed on that ship. So breaking it down, on the left-hand side, we've got the passenger cabins. That's where we're coming from. We've now got control over the core network. It's not a great situation. That core network carries traffic for the safety management system. An interesting thing, and I've just skipped too many slides. Sorry. Oh, you've seen the big reveal now. Interesting thing with the safety management system was they had these remote tablets. So if there was an emergency situation and you needed to manage that from a firefighting point or something like that, you could take a remote tablet and deal with that. It was a Windows tablet, which meant we could get the Wi-Fi password that accessed the safety management system from there and get the passwords for the safety management system. So we've compromised the Wi-Fi aspect of that. This is a genuine picture from a test. The password was set to 1234. Our recommendation was to make the password stronger. The client's response? Yeah, not great. So we've now got access to the safety management system. We can control watertight doors. I mean, watertight doors are serious things. They're these massive hydraulic doors deep down in the vessel that you can move backwards and forwards. We can control ventilation, firefighting pumps, and so on. So safety management system's compromised. I've already talked about how we've got control over the voyage data recorder. We've got control over the fire alarms. We can brick them now from the safety management system. Not a great situation. Now you'll notice I've split the cabins into officers and passengers. Now the network had been configured so that officers could connect into the ICMS, the control systems, with a read-only view. So if an alarm goes off, if something bad happens, they can have their laptop, a desktop computer, and they can see what's going on the control systems. It was done using RDP, so just a remote desktop onto the ICMS system. And when we connected over that, it was a read-only view. You couldn't, even if you logged in as those secret chief and engineer accounts, you couldn't change anything. You couldn't change any settings. So it seems like that's quite secure until you go to File, Print, and then you get the dialog come up and you open Command Prompt, and you've got a breakout, and it's an admin user. So now we've got an ICMS host where we've got admin, full admin on that box. The situation is now from the passenger network, we can go through to the ICMS and log in as admin. Pretty serious situation to be in. Now this little orange line there, we're going from the engine room systems through to the ASIPod systems. And we didn't really understand what that connection was. How are commands being sent from the engine room systems through to the ASIPods? And we needed to understand that. Now, a common way of industrial control equipment talking to each other is discrete serial connections, or discrete I/O, just things turning on and off with individual wires. The problem is you end up with lots of wires. You don't want lots of wires. So if you compromise one of those, you can only compromise the device on the end of it, and you can't move out of scope. I might be able to turn something on or off, but I'm not going to be able to RDP over a serial connection. But people have converged these networks. They've moved to serial over IP. So there'll be a host, there'll be a box that takes 20, 30 serial connections, and it will ram it down one Ethernet cable to the other end where they'll pop out all in one go. The problem is that Ethernet connection is not just designed to take serial. It can take RDP, SSH, whatever I want it to. If I compromise one end of that, I can remote desktop through to the other end, compromise the host at the other end, and if there's other networks on the end of that, I can then pivot through that device. IP is so much more risky than serial. It's a routable network. You can't do that with serial. So why does this matter? Well, once again, we've got that privilege of a tester on board. We could look at the documentation. And we looked at the documentation. And you can see there, in the dotted red line there's a card in a pack. A pack is a programmable automation controller. It's like a PLC, but runs Windows and is less good. It's got a connection there labeled serial, and it's got 4 ports on it. And then it goes through, and it hits a firewall, and then a switch. Last time I checked, serial doesn't go through firewalls and switches. This was Ethernet. It was serial over Ethernet, but it had been labeled serial on all the diagrams. And I think that meant that people thought the risk was the same as a serial connection. We went full inception. I think we are 4 layers of remote desktop deep by the point we got here. But we're now RDP'd onto one of the controllers on the ASIPod system. It wasn't just serial. We did need to recover hashes from the AsiPod system and carry out a brute force attack, again, something that other people wouldn't have the privilege for, but the passwords were not good. So the situation is now we've got all of these different things compromised, which means from my cabin, I've got the ability to control the AsiPods on the bottom of the vessel. So that's not great in the general scheme of things. The thing is, you might say you're still on the ship. Now, I'd like to hark back to Speed 2, where in fact he was still on the ship, so I've achieved the goals of Speed 2. But we want to do this remotely, don't we? Our good old friend, TeamViewer, comes back. Now, this isn't from this particular situation. These are the screenshots from the oil rig with that jump box. TeamViewer Personal was installed on a device, and of course we could connect remotely. Where did that happen on the cruise ship? It was the cabin control system. Now, we only found this because we were in the engine control room, and next to the engine control room is the hotel control room, the thing that does HVAC, water, and so on. And I could see on the cabin control system, in the system tray, TeamViewer sat there. I got my colleague to distract people whilst I looked for the password in TeamViewer. The password was long and of relatively good quality, but it was a fixed password for that ship. It wasn't managed centrally. Let's just say that, again, it was one of those passwords where you've got reason to believe it would be the same across lots and lots of different ships. It was related to the vendor name. So we've now got control over the cabin control system. So I could turn lights on and off, mess about with the HVAC and stuff. It's not the end of the world, though, is it? But then we had a look at the cabin control system. And at the top there, we noticed it's got outdoor temperature, relative humidity, AC temperature, and so on. It's got other feeds. It could also tell you what the seawater temperature is. Where would it get them from? Well, it would get them from the ICMS system. That's where what would know what the sea temperature is. So we've got another one of these connections we don't understand. Guess what? I used Modbus again over Ethernet. So we've got exactly that same situation where that connection could be something low risk, but it's not. So from the CCS, we can now carry out all of those different exploits. So remotely, take control over the CCS using TeamViewer, go through to the ICMS that we've got admin rights on, take control of some controllers I've not even mentioned, through to the AsiPod systems, and I'm sat on my sofa at home in my pants with TeamViewer, able to control the AsiPods on a cruise ship, which was really good fun. I honestly didn't think it would be possible. So what can we take away from this? Well, first off, work out impactful attacks with minimum effort. The thing is quite often we want to come up with these crazy things like steering a cruise ship. Realistically, bricking one of those controllers would probably have as much impact. Ransomware on the shop systems would probably have as much impact. Be lazy. Really, just do this. Always try to minimize the amount of effort you have to go to. If you can get passwords for a system by stealing a notebook off the chief engineer, do it. Wait, no, sorry, I don't advise that. Undocumented stuff is absolutely everywhere. Every ship we get on, there's things, even brand new ones, there's systems that are not documented. People don't understand how they're connected. Convergence and modernization introduce new risks. Most of the people on ships, the people who design ships, are thinking about things the way they were 10 years ago, not the way they are now with TCP/IP everywhere. Watch your third parties. Every third party who gets on board your ship, do any of you own ships, yachts, even a boat? If someone gets on your ship, into your office, whatever, watch what these third parties do. They will put remote access in if they can. Crucially, I think it's worth saying not finding an issue can be as useful to your client as finding an issue. If you can prove something's secure, if something's difficult to do, then that is very, very useful to them. So yeah, that's my talk on hacking cruise ships. I'd like to dedicate this to Nigel Hearn, a colleague of mine who we lost yesterday, because he sold most of these jobs. He sold the first job, and I'm cracking up now. So this is dedicated to Nigel, who we lost yesterday to cancer. So thank you, everybody.
Well, Andrew, thank you very much for an incredibly thorough walkthrough of a ship, and I'm going to be petrified the next time I set foot on one.
So you should be.
So you should all have a version of gin now. We've had a few requests for the non-alcohol ones. I've actually got one here. It actually tastes quite nice, so I'm very happy. Anyway, we've all lost people. This is life. But it's been a very poignant 3 years. Everyone knows someone who's been lost due to COVID. That's the reality. But we've had people die of other things, as Andrew just pointed out. Cancer treatment has been incredibly hard the last 3 years because my sister is a cancer specialist. She's had great trouble even seeing patients, let alone treating them. So it's been really, really difficult. If you want, you can dedicate this to the recent royal loss. If you want, you dedicate it to someone that you know or knew. But here is a toast to absent friends at 44Con. And with that, food is outside.